We're going to move into hypothesis testing involving two population proportions now. And it turns out the process is going to look really similar to the hypothesis testing process we used in Chapter 5. It turns out that the steps are all kind of the same. Of course, there's some small tweaks here and there. But the first step is still going to be we want to set up what is our null hypothesis and what is our alternative hypothesis. So that's all we're going to do in this video. We're just going to look at this hypothesis testing problem and try to determine what our null and alternative hypotheses should look like. So the question that's being asked here, it says, is there a difference in the proportion of all Duke students and the proportion of all U.S. adults that would be bothered a great deal by the melting of the northern ice cap? So in these types of problems, we're always going to see two separate populations. One of my populations is all of U.S. adults, and then one of my populations in this case is all of Duke students. So I've got two separate populations that I want to consider here. And of course, we're still talking about proportions. We're talking about proportions of each of these, which means that my parameter is still going to be a proportion, although in this case it's going to be P1 minus P2. Anywho, we want to set up what is H0, and we would like to say what is HA. Now, the nice thing about these types of problems is that the null hypothesis is always the same regardless of what claim is being made, what question that's being asked, as long as we're working with two separate proportions. Our null hypothesis is always going to be that P1 is equal to P2. Now, we're operating under the assumption in these types of hypothesis testing problems that the null hypothesis is true. So what we're going to begin this problem by assuming is that the two proportions are in fact the same, and then we're going to see, well, what happens if that's true? What conclusions do we arrive at if that's true? Now, you may have a difficult time remembering which one is population 1 and which one is population 2. If you have, something you can write down on, I would recommend doing one of two things. Either labeling on your paper somewhere saying, okay, U.S. adults, that's going to be population 1, and Duke students, that's going to be population 2. That's one way we can approach this. Another way is just to use completely different subscripts instead of 1 and 2, just so that we know which one is which. You could also say something along the lines of the proportion of U.S. adults is equal to the proportion of Duke students. You could actually just go ahead and label your proportions. I don't really have a strong preference either way. I will say it needs to be clear to both you and to me when I'm grading your work on quizzes and tests, which is population 1 and which one is population 2. In these videos, I'm primarily going to be using population 1 and population 2 just because those are the formulas. That's how the formulas that we're going to be using are written. But if you would like to use P sub US and P sub Duke, that's totally fine. That will get the job done here as well. So, of course, once we have that established, the alternative hypothesis is going to depend on the language that's being made. And if I go back and I read the question that's being asked here, it says, is there a difference between these two proportions? It's not claiming that one of these proportions is greater than the other. It's just saying, is there a difference? Which, of course, makes me think, oh, this is not a left-tailed test or a right-tailed test, but this is going to, in fact, be a two-tailed test. So that means that the proportion 1 will not be equal to proportion 2, or if you'd rather use this, P sub US is not equal to P sub Duke. The nice thing about the method of hypothesis testing that we'll be discussing is that the language that's being used is basically the same for left-tailed tests, right-tailed tests, and two-tailed tests, and they're constructed basically the way that you would expect to see them. So there's not really going to be any surprises. If you felt comfortable with the hypothesis testing procedure in the last chapter, then the good news is this is kind of just building on that. It's just saying, okay, what if we modify this to allow for 2 proportions instead of 1? And if you didn't feel super confident, then this is another opportunity to practice and get used to that, because this is going to be a procedure that we're going to be using a lot going forward in this class.